Let's try to interpret one last titration curve. This time, this is for histidine. So we start again with the fully protonated form of histidine. Its side chain has this functional group. One of the nitrogen atoms in this cyclic chain can accept a proton. So you have the proton there. The net charge of the molecule is +2. So for the first dissociation, again, it's the proton from the carboxyl group. And now the net charge of the molecule is +1. Next, we have the proton from the side chain getting removed, and the net charge of the molecule is 0. And finally, the proton from the amine group is removed, so we have a molecule with a net charge of -1. So for the titration curve of histidine, again, we observe a slight rise in pH, followed by the buffer region. And this is where we see the first pK value, or the pK for the first dissociation. So there's pK1 equal to 1.82. So at this region, the components of our buffer are the form with a charge of +1 and the form with a charge of +2. Then we see a steep change in pH. So this is our first equivalence point. So we see again a buffer region. In this buffer region, we determine the value of the pK for the side chain. This is the second dissociation reaction. So we have the two components, the form that has a charge of +1 and the Zwitter ion. As we continue to increase the pH, we observe a slight change in pH. So this is still an inflection point. And then we see the third buffer region. So this is for the third dissociation reaction. In this buffer, the two components are the Zwitter ion and the molecule with a charge of -1. And again, we don't see the third equivalence point. Just like the others, the third equivalence point is not visible because it happens at a very high pH value. This time, we see that the equivalence points are very distinct, unlike the one for your glutamate. Because in glutamate, you have two carboxyl functional groups. So their pK values are very near each other. That is why we hardly see the equivalence point between the two pK values. In the case of histidine, the structures, the three structures, are very different from each other. So we have the carboxyl group, the amine group, and this cyclic chain. That is why we can see the pK values are more spread apart from each other. And we can see the equivalence points in between these pK values. Lastly, we can determine also the PI, or the isoelectric point of histidine. So again, this is our Zwitter ion. So the two pK values flanking this Zwitter ion is the pK for the side chain, which is 6, and the pK for the amine group, which is 9.17. So get the average of these two values, that is the isoelectric point of histidine, equal to 7.59. So if the pH of the solution is equal to 7.59, all of your histidine molecules have a net charge of 0 and they will precipitate out of solution.